again, we're comparing the bits of the default mask and the subnet mask. In the portion where the default mask and the subnet mask both have zeros, right here, these are our host bits. And I just noticed a mistake up above, and I know you guys noticed, and you guys know what's going on. It's supposed to be a 255, so let me change that. Anyway, these are our host bits. Right here, the last ones where both the subnet mask and default mask has zeros. Now the section where they share ones, and they are all ones, that's the network section. That does not change. And where the default mask has zeros, but where the subnet mask has ones, those are subnet bits, and we borrowed those from the host bits. Now where the default mask has zeros and where the subnet mask has ones is the subnet bits. If you remember, I said subnetting is always about borrowing bits from the host bits, never from the network bits. And now by writing those out quickly in binary, we know how many subnet bits we have. We have 8. So, according to that formula, 2 to the 8th power is our answer. You may ask, well, how do I know what 2 to the 8th power is? Not too many of us really use powers of anything. It's an exponential function. It's mathematics usually used by engineering students. So I just write it out. Whatever number of 2's it is, 2 to the 8th power is 8 2's multiplied together. So let's do that. Just to show you, it's 2 times 2 equals 4 times 2 equals 8 times 2 equals 16 times 2 equals 32 times 2 equals how many? 64 times 2 equals 128, and times 2 equals 256. Let's count that. We've got 2, 3, 4, 5, 6, 7. That's our 2 to the 8th power, because that's 2 multiplied 8 times. It is 256. And this is the only type of question where you need to look into the config also to see what they're using, like just in case. If it's an old router, in case you see no IP subnet 0 or classical protocol like RIP version 1 or IGRP, then you subtract 2. But I'm telling you, you're never going to do it. You're never going to see it again. Certainly not in your exam. Don't be confused by this. Old routers, yeah. You can practice on your own here, and you could practice with some classful number like, say, 25.0.0.0, for instance. And just come up with a subnet mask on your own and say, what's the deal here? And come up with the valid subnets that you end up with. So now we're going to take a look at how to determine the valid number of host addresses. But before we do that even, we're going to learn what prefix notation is. And you may have figured it out just by looking at things. Now prefix notation is that slash notation, like, say, /24. Now using our examples here, if you look at the default class B and C masks, they all begin with 1's, right? And prefix notation is simply a slash followed by the number of 1's in that mask. In other words, it represents the binary. It's a shorthand way of expressing the binary version of the mask. So let's look at them again. /24 is the same thing as 255.255.255.0, or it is also the same as 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Those are all the same. And it's a lot easier to do /24. A lot quicker, means the same thing, right? So what's the Class B default mask in slash notation? Right, 16. And it is, whoops, there I go again. And it is also that's it. Those are all the same thing, slash 16, 255.255.0.0, or all ones in the first half, all zeros in the second half. It's a 16-bit mask. That's all there is to it. In Cisco exams, you will see the masks indicated, well, I was going to say both ways, but all three ways. Binary, decimal, and slash. Because it is perfectly possible that Cisco is going to ask you to calculate a subnet mask. And then in the answers they may say, choose two. You'd need to be comfortable with all ways of answering this, whether it's binary, slash notation, or dotted decimal. They may even test if you know this by doing this to you. That's what they do. They test you all kinds of ways. They slide it in there. They make it like a 2 for 1, 3 for 1, 4 for 1 question just to prove whether you know your stuff or not. They'll mix it up. I guarantee it. There is more than one way to express this, so be prepared. And frankly, in most network diagrams, you'll see the slash notation. And now let's see, the next calculation that we have to do for the real world or for the exam is determining the number of valid subnet hosts. Determining the number of valid hosts given a subnet and a subnet mask. Now, the formula is somewhat similar to when you were calculating the valid hosts on a subnet. But watch this, because when you were doing validating the subnets, we used 2 squared by the number of subnet bits in that case. And here, we're using 2 squared by the number of host bits, minus 2. And thankfully, we'll always be subtracting 2 here. No quibbling about it. And it's actually to remember this because when doing subnets, it's 2 squared by the number of subnet bits. When doing subnets, it's 2 squared by the number of subnet bits. And in valid hosts, doing valid hosts, it's 2 squared by the number of host bits. So they've got the appropriate word in the equation. And there is no lecture on it because you subtract 2 all the time. And if you're like me, you're going to ask, why is that? Why do you subtract 2 all the time? So just bear with me. We will soon get to that. You'll see why when we determine the range of valid addresses, we subtract 2. It's because we remove the endpoints. But right now, I just want you to know how many valid host addresses we're getting with what we're given. So let's do this. With this particular subnet mask, let me get this out of the way. And let's take a look at this. With 150.50.50.0/24, given this subnet number and mask. I'm throwing the prefix notation at you too, and given this, we need to be able to calculate how many valid host addresses are on this subnet. And right off the bat, we need to know what class that subnet belongs to. And what is it? It's Class B. And we know what the network mask is for this too. That or /16. So let's write this out in binary. The network mask is and the subnet mask is since /24 indicates 24 ones. Now, where it shares ones, that's the network bits. And where it shares zeros, this is why I'm writing this out side by side. Where it shares ones, it's network. Where it shares zeros, that is the host bits. And where the network mask is all zeros and the subnet mask is all ones, that's our power of 2. Those are the subnet bits. When you see 255, it's a gimme. It's easy for you to figure it out in binary. You know that that octet is all ones. And in the last part of this lesson, we talked about where the host bits are. Host bits are where the network mask and the subnet mask have zeros together. So valid host bits is 2 to the 8th power minus 2. So that's easy. If it's 2 to the 8th power, you know that's 256. And minus 2, that's 254. So with 254, I'll explain why we subtract 2. The 2 hosts that we take out, this accounts for both ends of the subnet range. It accounts for the network number itself, which is the first IP address, and the broadcast address for that subnet, which is the last one. The first number in the range is network number, the last is the broadcast address. You should not consider either a valid or usable IP address. Now, another question type that you may see on your exam also, and this is really important for network troubleshooting. What if someone has already put a subnetting scheme into action and someone adds to it later on? Or maybe there's trouble right after they roll it out even. Whatever it is, you're a little concerned about some of the addressing used, and you want to look at an IP address in this case and determine what subnet number it belongs to then. So again, what we need is this ability to analyze it and look at the host IP address or router's IP address and determine what subnet does this belong to. Let's make sure our problems aren't there. This is a fundamental troubleshooting question.